Let's imagine the feature set being formed one feature at a time. First, our feature set is empty, then it gets one feature, let's say that's age, then it gets another feature, that's DBP, and finally, it gets SBP. We can now find out the contribution of SBP when it joined the feature set by computing the prediction of the model with the three features minus the prediction of one with just age and DBP, which came before SBP into the feature set. Another possible way the features could be formed was that age comes first, followed by SBP, followed by DBP. Here we can find the contribution of SBP when it joins the feature set by computing the difference of a model that uses age and SBP minus one that just uses age, which is the feature that came in before SBP, to get 0.53. We can imagine all possible ways the feature set might be formed. Because there are three features, there are 3 factorial or 6 ways this feature set can be formed. For each of these, we can compute the importance of SBP against the features that appear before it. For example, in third row, second column over here, SBP appears before both age and DBP, so we compute the output of the model with SBP only minus the model with the empty set and take the difference. Finally, we average all of these feature importances, the sum of these 6 numbers, divided by 6 to get us the average, which gives us the importance of SBP for patient A, which comes out to about 0.38. We call this importance the Shapley value, represented by capital I, for SBP for patient A. We can similarly compute the Shapley values for age and for DBP. Notice that the contributions of SBP and DBP look much higher relative to age and before, and this is capturing that these two high values are driving the risk for this patient. Another cool property of Shapley values is that the Shapley values sum up to the risk prediction with the full model minus the base risk in the population. In other words, the Shapley values are telling us how much each feature contributes to the additional risk over the baseline risk of the population. So here's another patient in a new data set, and the prevalence in this new data set is 0.001. We have 3 Shapley values for the 3 features for this patient, which all add up to form the output with all of the features, which is 0.26, minus the output with no features, which is going to be the prevalence, getting an output of 0.26. So we can visualize these Shapley values and their total using a force plot. On a force plot, we have the output value of 0.26 and the base value of 0.00, and this distance is going to be covered by the sum of these 3 Shapley values. So we can see that the contribution of DBP is 0.01, which is represented by the length of this segment over here. The greatest contribution, of course, is by SBP, which is a contribution of 0.3 in the positive direction, and the contribution of age is negative 0.05. Now, age is forcing the output in the lower direction, so it's blue, while SBP and DBP are forcing it in the positive direction, so they are red.